This is the video 10 of MEKG video series. In this video, marine boiler topics are discussed. Topic 1: Combined shutoff and feed valve.
Some boilers are fitted with a combined shutoff and feed valve accommodated in the same valve chest, used in both the main and auxiliary feed lines. The shutoff valve is a screw-lift valve, which is located between the non-return feed valve and the boiler. The boiler pressure is exerted on the screw-lift valve. The non-return feed valve avoids the risk of boiler contents discharging out of the feed line in case of rupture of feed line. Combined shutoff arrangement allows the non-return feed valve to be isolated and overhauled as screw-lift valve is shut whilst the boiler is in operation and steaming.
Topic 2: Blowing through boiler gauge glass.
Process of blowing through boiler gauge glass. Close the steam and water side valves and open the drain valve. Blow through the steam side by opening the upper steam valve for a few seconds, then close. Blow through the water side by opening the lower water valve for a few seconds and close. Close the drain valve. Open the water valve, followed by the steam valve. For the safety of personnel, gauge glass cocks can be operated remotely. This is in the event of the breakage or crack of gauge glass, which can lead to injury of personnel in the vicinity.
Topic 3: Air register.
This is typical arrangement of air register. The word air register is given to the assembly of vanes, air swirler plates, and so on, fitted within the boiler casing in way of each burner position. Functions of air register are to divide air into primary and secondary streams and to guide these streams so as to impart the correct airflow pattern. To achieve proper mixing of air with hollow rotating cone of oil particles. The air must pass through the air check to enter the register. In some cases, the check can be formed by the swirl vanes themselves by rotating them about their axis. In most of the cases, a sliding sleeve is used. Air check may be operated by hands or may be automated by using pneumatic means. The inner primary air flows until it reaches the tip plate, stabilizer, then spills over to form a series of vortices, which reduce the forward velocity of the air. This retains the primary flame within the coral. The outer, secondary air passes over the swirler vanes, which causes the air to rotate, thus assisting in proper mixing of air and fuel in the secondary flame zone. A small amount of cooling air is allowed to flow to the tip plate and atomizer tip.
Topic 4: Rotary Cup Burner.
Rotary Cup Burner. Rotary cup burners work on the principle of atomizing oil by centrifugal force. The V-belt is connected to an electric motor that drives the rotary cup shaft of the burner. The atomizing cup is attached to the rotating shaft mounted on ball or roller bearings and rotated at high speed of between 2,000 to 7,000 RPM. The heated oil is supplied at low pressure into the spinning cup, where it is imparted centrifugal force by the centrifugal action of the spinning cup. Due to high rotational speed, the centrifugal force causes the fuel to spread out evenly into a thin film. The fuel then moves along the taper to the end of cup. As it passes into the surrounding airstream, the fuel is atomized and broken into very fine droplets, and finally leaves the burner tip as a hollow rotating cone of oil droplets. And then the combustion process starts.
Topic 5: Automatic combustion control system.
You can see the schematic diagram of an automatic combustion control system used in a boiler plant. This system has 4 measuring elements. A steam flow sensor, which measures the flow rate of steam in the boiler. A steam pressure sensor, which measures the pressure of steam in the boiler. A fuel flow sensor, which measures the fuel flow in the boiler burner. An airflow sensor, which measures the air to the boiler. The 2 controllers in this system are a fuel flow controller, which regulates opening and closing of fuel valve. An airflow controller, which regulates the airflow by opening and closing of dampers. The steam pressure and the flow signals are transmitted to a computing relay. The computing relay generates the master signal depending on the load of the boiler. This master signal represents the fuel requirements to the boiler. The master signal is fed at a set value to the low and high signal selectors. In the low signal selector, the master signal is compared with the signal representing the airflow. The selector passes the master signal only if it is lower. In the high signal selector, the master signal is compared with the signal representing the fuel flow. The selector passes the master signal only if it is higher. When the steam demand is high, high signal selector passes the master signal to airflow controller. The airflow controller increases the airflow by adjusting the damper position. As the airflow increases, the airflow sensor transmits the signal to the low signal selector and airflow controller. The master signal passes to the fuel flow controller to increase the flow of fuel by adjusting the fuel valve position. If demand is low, the low signal selector permits the master signal to pass to the fuel flow controller. Fuel flow controller decreases the flow of fuel by adjusting the fuel valve. As the fuel flow decreases, the fuel flow sensor transmits the signal to high signal selector and fuel flow controller. The selector sends the master signal to the airflow controller to decrease the airflow by adjusting the damper. In this way, the control system maintains the air-fuel ratio and prevents incomplete combustion of fuel with changing steam demands.
Topic 6 Operational Procedures of Auxiliary Boiler.
A typical layout of auxiliary boiler system is shown. The fuel oil pump takes suction from the diesel oil service tank or heavy oil service tank through the 3-way changeover valve. The pressurized oil is supplied to the boiler burner through a solenoid valve. The pilot burner is fired first to light up the main burner. A flame sensor senses the flame of the pilot burner and actuates the fuel oil solenoid valve for the main burner. Feed water pump takes suction from the hot well and discharges to the boiler drum through feed water regulator. The feed water regulator maintains the water level in the boiler according to the steam demand. Before starting the boiler, you have to carry out a few checks. Check whether all mountings are fitted in place. Check whether all inspection doors are fitted back. Shut the main steam stop valve. Open the air purge valve. Open the feed water pump suction valve, delivery valve, and boiler feed water valves. Start the feed water pump and fill the boiler up to 1/4 of the gauge glass manually. Stop the pump. Position the changeover valve to pass diesel oil. Open the fuel oil pump suction and delivery valves. Open the heater bypass valve. Close the heater inlet and outlet valves. The boiler has to be fired manually for a short duration at regular intervals to warm it up. If fired continuously, thermal stresses will be induced on the shell. Start the fuel oil pump. Start forced draft fan. Wait for at least 3 minutes to purge out the furnace space. Press the ignition button to ignite the pilot burner. Start the main burner in manual mode. As the main burner lights up, stop pressing the ignition button. Stop the main burner after 30 seconds of firing. The boiler has to be warmed up according to the maker's recommendations. As the boiler warms up, the water level rises in the gauge glass. After the water level stabilizes, start the feed water pump and put the regulator in use. Steam will start blowing out through the air purge valve. Shut the air purge valve. Fire the burner in auto mode. It will cut off at the set value of 9 bar. Crack open the main steam stop valve. Gradually open the main steam stop valve to fully open position. The burner will start firing automatically as pressure in steam drum reduces. The boiler is changed over from diesel oil to fuel oil, as steam is available for heating the fuel oil. Heat the fuel oil service tank to 80 degrees Celsius. Open the heater inlet and outlet valves. Close the heater bypass valve. Open the heater steam valves. Steam pressure is maintained by automatic operation of the burner. Pressure switch controls the burner according to the set pressure values. Alarms are provided to warn the operator of low and high steam pressures. Fuel oil temperature is maintained at the required value for proper combustion automatically. It is done by controlling the flow of steam to the heater. The local temperature gauge should be checked periodically. The feed water regulator maintains the water level in the boiler at half the gauge glass level. A water level sensor sends the signal to a controller which controls the feed water regulator. The boiler feed water pump runs continuously. If the water level decreases below the set value, an alarm is sounded to warn the operator. However, the water level of the level gauge mounted on the boiler should be checked periodically. Close the main steam stop valve. The burner will cut off when the steam pressure reaches the set limit. Change over the burner to manual mode. Stop the fuel oil feed pump. If the boiler is shut down for longer duration, then it should be changed over to diesel oil before stopping the pump. Stop the feed water pump. Change over the burner to manual from auto.
Topic 7 Boilers Safety Devices.
The high-level water alarm is activated when the water level in the boiler increases above the set value. The low water level alarm is activated when the water level in the boiler decreases below the set value. The low water level trip will stop the firing of boiler if the boiler water level falls below the set limit. The boiler feed water low temperature alarm is activated when feed water temperature decreases below the set value. The boiler feed water low pressure header alarm is activated when boiler feed water header pressure decreases below set value. The high salinity alarm is activated when water salinity rises above the set ppm limit. The high steam drum pressure alarm is activated when the steam pressure increases above the set value. The low steam drum pressure alarm is activated when the steam pressure decreases below the set value. The combustion air low flow alarm is activated when the combustion air flow decreases below the set value. The low atomizing steam pressure alarm is activated when the atomizing steam pressure decreases below the set value. The low atomizing steam pressure trip is activated when the atomizing steam pressure decreases below the set limit and the boiler operation will be stopped. The low control air pressure trip is activated when the control air pressure drops below set limit and the boiler operation will be stopped. The low fuel oil pressure alarm is actuated when fuel oil pressure decreases below the set value. The low fuel oil pressure trip is actuated when the fuel oil pressure decreases below the set limit and the operation of the boiler will be stopped. The high fuel oil temperature alarm is actuated when fuel oil temperature increases above the set value. The low fuel oil temperature alarm is actuated when the fuel oil temperature decreases below the set value. The low fuel oil temperature trip is actuated when fuel oil temperature decreases below the set limit and the operation of the boiler will be stopped. If the fuel oil pump fails, it will actuate the trip and boiler firing will be stopped. If the forced draft fan fails, it will actuate the trip and boiler firing will be stopped. The flame failure trip is actuated on failure of flame and the boiler operation will be stopped. The flame scanner failure trip will stop boiler operation. The high smoke alarm is actuated when the smoke levels raise above the set limit. Pilot burner ignition fail trip is actuated when pilot burner fails and boiler operation is stopped. Main burner ignition fail trip is actuated when main burner fails and boiler operation is stopped. The power source failure trip will shut down the boiler.